All right, microphone on. All right, this is my third time recording this. It's fun, not mad at all, I guess. So this problem is asking. This is number 5 for WebAssign 6D, torque, or I forgot, rotational something. Yeah. Okay. So, rotational dynamics is what this is. What it's called. So. Question asked, an electric motor turns a flywheel through a drive belt that joins a pulley on the motor and the pulley that is rigidly attached to the flywheel as shown in the figure below. The flywheel is a solid disc with a mass of 74 kilograms and a radius of r equals 0.625 meters. It turns on a frictionless axle. Its pulley has smaller mass and a radius of 0.23 meters. The tension TU in the upper taut segment of the belt is 171 newtons, and the flywheel has a clockwise angular acceleration of 1.67 radians per second squared. Find the tension in the lower slack segment of the belt. So here I'm going to label the upper taut segment TU, like it asks, and the lower segment is TX. And since the flywheel is rotating this way, at this moment the tension will be pointing this direction, opposite of TU, or so we think. I'll get to that in a little bit. So we have the mass 74 kilograms, angular acceleration of 1.67 radians per second squared. The upper segment has a tension of 171 newtons, and here I just put it all in here. We know that TU and the tensions will be perpendicular to the center. So right there. All right, so here we have a torque equation. We know that torque equals the cross product of radial distance and force. But since the tension is perpendicular to the radius to the center of the circle, there is no angle. So we just have it here as the TU times the radius little r plus TX times radius equals moment of inertia times angular acceleration. Or it's the same as, like, if it was linear, it would be F equals ma. So we know that the moment of inertia for a disk is equal to 1/2 mr squared. And you may be asking or wondering, why is this a plus if they're going in opposite directions? Now, the thing is that you got to think about is that they're not going in opposite directions. They're actually going in the same direction. Even though the picture looks like they're going in opposite directions, plus minus directions, they're actually both going clockwise, which means that they're going the same directions at different times. All right? Not different times, but, so you're actually adding. So just think of it as this way. If this was a linear motion and this was a free body force diagram, I don't know, I just made one up, bear with me. You have it here. You have this as your y component would be Fn1 plus Ft equals Ma. It wouldn't be Fn minus Ft because Ft is in the same direction as Fn. So you would add, which is what the case for this torque equation. Which is why you add here. So here I'm just going to do a little math, factor out the radius of the smaller pulley, because we have to remember that the angular acceleration and big R are related to the flywheel, which the flywheel is the big thing, this big one, and it's turning clockwise. The pulley is this little circle. So do a little math, get the R over here, rewrote it a little bit over here. So we have Tx equals negative Tu plus, and it's just Tx because why not? I just named it that. I guess it's TL, lower. So now it's just plugging in. So we know that TU is 171 newtons, so negative 170 newtons, plus the angular acceleration, 1.67 radians per second squared times 74 kilograms times 0.625 meters squared, all over 2 times 0.23 meters. And you get negative 171 plus 105. Now the thing is, the answer that you actually get is negative 66.1. And you might be wondering, why is the answer up here positive? And it goes back to what I was saying before and how it may look like these are going in different directions. but they're both going clockwise. So they're actually both going in the positive same direction. So here, 66.1 will be positive because they're going in the same direction. And the answer when you get here is actually negative, but it's actually positive. Now, I got it right. 66.1. This problem is not that bad. I had a little problem with it at the very beginning when I first did this because so when the first time I did this, I subtracted because I thought, oh, they're going the opposite directions. But I didn't realize that they were going the same direction, so I actually had to be adding. So that's one way I could see a lot of people messing up. Other than that, it's not too difficult. Maybe you get the moment of inertia a little mixed up. Maybe you plug in the radius for the smaller pulley to the big flywheel. But yeah, this problem wasn't that bad. I think the hardest concept here was the adding instead of subtracting because you had to realize that they were going in the same direction and that they were perpendicular, so you actually didn't have to use any angles for the cross product, for the torque. And other than that, when I did this, the first video, first time I recorded this, I accidentally plugged this into my calculator wrong. So another thing, if you're plugging something into your calculator, that's another problem. Other than that, this question wasn't that bad. And yeah, that's